Hey guys, welcome to question MM404 of the Maths Methods Fortify study guide. So, in this question we've got, let x be a normally distributed random variable with a mean of 48 and a standard deviation of 6. Okay, so I've drawn this on this normal distribution scale, standard deviation of 6 going up. So plus 6, plus 6, plus 6, and then minus 6, minus 6, minus 6. Now, given that probability that z is greater than -1 equals 0.84, corrected 2 decimal places, find A, the probability that x is less than 42. Alright, awesome. So, if we know that z is our standard normal distribution, or standard normal random variable, that means that it determines how many standard deviations away from the mean we are. Okay, so what we're saying here is that the probability that z is greater than -1, so from here onwards, is 0.84, right? Now, we're looking for the probability that x is less than 42. Okay, so this is these are our x values, and these are our corresponding z values. Now, if we know that 42 corresponds to a z value of -1, then that means that if this is 0.84, everything on the other side must add to 0.84 to get to 1, right? Because this whole thing has to equal 1. So if this is 0.84, then this bit here is 0.16. So that means that the probability that z is less than -1 equals the probability that x is less than 42, because they correspond to each other, right? So that is the same thing there, which equals 0.16. And that's our first and final mark for part A. Let's move on to part B. Part B can be a little tricky if you haven't seen questions like this before, but let's break it down for you. Actually, I'll probably leave that there. So, part B says, find the probability that x is between 48 and 54. So again, this is a 1-mark question, and what we're looking for is this probability in between here, 48 and 54. Now, what we know is, from the previous question, and what the information the question gives us, is that the probability that x is less than 42 is 0.16. We figured that out in the first part. Which means that everything above 54 is also 0.16, right? Because normal distributions are symmetrical. So 42 is 1 standard deviation away from the mean, and so is 54, which means that all the probability on either side is the same. Okay, so 0.16 and 0.16. Now, because this is symmetrical about the mean, actually, firstly, if this is 0.16 and this is 0.16, that's 0.32 all up, which means that this is 0.68, right? Because all of this has to add to 1. So if this is 0.68 and this section here is symmetrical about the mean, then that means that half of this lies here and half of this lies here. Now, 0.68 divided by 2 is 0.34, which means that the probability that x is between 48 and 54 equals 0.34, which is our first and final mark for part B. Guys, if you don't understand this or anything, please, as always, hit me up in the comments below. It's just the symmetrical properties is what you really need to pay attention to. So that's it for part B. Let's move on to part C. Part C brings in conditional probability within our normal, and this is 2 marks. And we're asked to find the probability that x is greater than 54, given that x is greater than 48. Awesome. So, according to our given formula, which says that the probability of A given B, as I'm sure you've seen this before, probability of A intersect B over probability of B, means that we're looking for the intersect of these two. So, probability that x is greater than 54 intersect x is greater than 48 over the probability of x is greater than 48. Awesome. So, the intersect, again, is always the common ground between these two things. So what's the common ground between x is greater than 54 and x is greater than 48? Well, it's just x is greater than 54, right? Because if you can imagine this on a number line, if we have 48 here and 54 here, we've got x is greater than 54 and x is greater than 48. And what's the common ground between these two? Everything from this point onwards, which is everything above 54. So that means that our intersect is probability that x is greater than 54, and then we've got over probability that x is greater than 48. This is actually our first mark here. This is a 2-mark question. From here, we can now figure this out. So the probability that x is greater than 54, this is why it's really useful to draw a diagram, because you're going to be able to refer back to it later. So x is greater than 54 is from this point onwards, which is 0.16. So that's our probability there. The probability that x is greater than 48, well, 48 is our mean, and we know that 0.5 of the data lies on either side of the mean. So that means that the probability that x is greater than 48 is equal to 0.5. Now, we don't have a calculator, so we can't actually evaluate this. Sorry, we can't do it in our calculator. So the easiest way to do this is whenever you divide something by 0.5, it's the same thing as multiplying it by 2. So we've got 0.16 times 2, which is 0.32. That's our second mark. So 0.32 is our final answer for part C of MM404, guys. If you have any questions about any of this, as always, let me know in the comments below, please. I'd be more than happy to answer any questions. But for now, thank you very much for watching, and I'll see you in the next video.